Calc, it's problem 6-69. It says in triangle ABC, B equals 33 degrees, A equals 15, and B equals 10. Determine the missing measurements of all possible triangles. So what I usually do is just draw. I don't try to draw it accurately. I just usually draw an equilateral triangle or just any old triangle. And I label it. So they told me this, they gave me this angle, and they gave me these two sides. And as soon as I had it all drawn, I did a little bit of work ahead of time. As soon as I had it all drawn, I saw that I had side-side angle. And that made me think that I'm probably going to have, there's a possibility I'm going to have two triangles because I've got side-side angle. So what I do, instead of using law of cosines, which is, it gets kind of messy and it's kind of a hassle, I just go ahead and use law of sines. And law of sines is easier. So I have an angle pair right here. So I set up sine of 33 is to 10 as I wanted to find out angle A. So as sine of angle A, oh, I said 33. Oh no, did I set it wrong? Oh, no, okay. So anyway, I think I set this up right. And then I go ahead and solved it, put it in my calculator. So I just use the buttons in my calculator, calculated this, hit inverse sine, and I got an angle measure. So I put the angle measure in the missing spot, and then I look at my triangle and make sure that that is a viable measurement. I know that the smaller side, the smaller angle is going to have the smaller side across from it. This angle is a little bigger than this angle, but this side's a little bigger, so I feel okay about that. Now, to solve this triangle, it would be nice I could just get angles, or if I could just get angle C, I could use law of sines and find side C very easily. So I go ahead and subtract from 180, and I ended up, oh, actually I didn't do it yet. So angle C on this triangle is going to be just, well, now I guess I'll start doing some work. It's going to be 180 minus 54.78 minus 33. It's about 92.22. But there's something I did ahead of time. I don't know if you know this, but when if there's going to be two triangles, the angle measure, there's going to be one that's acute and usually one that's obtuse, or one that's, they're going to be supplementary. So this other triangle is going to have, I can get this angle measure without doing any calculations besides just subtracting what I got for this triangle from 180. So now I already know over here that the big A is 125.22. And I take a little, oh, and we knew this is the same thing, so this was 15 and 10. I just hadn't filled it out yet. So, and I'm looking at it to see if that's even a viable option. I see that the smaller angle is across from a smaller side, and that's a pretty big angle to be across from that side. And I can get this angle C by just subtracting from 180, like 180 minus 33 minus. It's really small. It's 21.78. So I'm kind of like solving both of the triangles all at the same time. And then I can get this side right here, because I already got this angle, since this is 92.22, I I can get the side. Did I do that? I don't think I did the side yet. So I'll just set up sine of 33 is to 10 as sine of 92.22 is to little c. So I go this times this divided by this. I'm just going to do it in my calculator if you don't mind. 10 sine divided by sine of 33. So I got C. So C is 18.35-ish. I hope these are right answers. And it's the biggest side, and it's across from the biggest angle. So I feel pretty good about that. So I'm fine, and I'm just boxing in. I know it's messy, but I'm boxing in all my answers. So it's like I'm just doing the whole, both triangles all at once. This one I have to do a sine ratio here I'm going to use, like that. So I'm going to say, and if I weren't explaining it, I could do it a lot faster. Sine of 33 is to 10. Yes. Sine of 21.78 is to c. Well, I'm going to just do it all in my calculator. So 10 times sine of, and then divided by sine of 33. So this little side, little c, that was supposed to be big C. Little c is 6.81-ish. And then I just look at my triangle and make sure it's okay. So the bigger side is across from the bigger angle. The smallest side is across from the smallest angle. So it looks like I did it. I'm going to check the answer key just to make sure that we match. Yeah, I think they have all the same answers. So this way, I like my way better. If you like to do the law of cosines and then put it and use the quadratic formula, that's great if you can do that without messing it up. But if you wanted to do it this way, that's another way.